Welcome to today's presentation, Product and Process Knowledge Capture for Construction. I'm Patrick Mays with Dassault Systems.
And I'm James Brown from Protex.
So James will be talking about process knowledge capture, and I'm going to talk about product knowledge capture. The example we're going to use is a multifamily building, a typical flat. Let's first talk about the way the units themselves are delivered, and then we'll talk about the core systems, which is where we're going to focus most of today's discussion. These are 2 or 3 megablocks per unit, and these units would be 2 or 3 bedrooms per unit. That's one way to deliver them. Another is what's called volumetric pods that include multiple trades. So electricians, plumbers, multiple trades would work on an individual pod in a factory, and then that pod would be delivered to a job site. A third way to deliver is panelized construction. This would typically be used for living rooms and bedrooms and spaces that don't create so much congestion between the different trades in the workspaces. Now, you could mix these together. You might have a mixture of volumetric pods with panelized construction together. Let's move from the units to talk about the core of the building, where the elevators and stairs are located. We're going to talk about 7 separate systems. I'll show them diagrammatically first, and then we'll get into some photographs from the field to show you what they look like in real life. The first thing that you're typically going to do on a construction site is some excavation to get access to the public utilities, and then you'll need to lay out some structural elements like columns to support your slabs. So in this first diagram, you can see the elevator core, the pit has been put in place, the first set of stairs has been put in place, and the columns have been put in place. The next sequence would be to add additional stairs to get to a floor above, and you'd begin to put in these mechanical, electrical, and plumbing risers. And then finally, you'd put in another level, which is just for the core only. The slab for the core gives you access to the lift, the stair, the MEP risers, and the other elements. On the ground level, there is a larger podium slab, and the units are self-supporting on top of that slab. Let's go to some photographs in the field so you can see what these look like. So on the left, you can see there's columns being placed in the field, and you can use a system which either has shear caps on top of the columns, or you can have beams that bridge between them. In the middle, you can see a slab being placed. It's a precast slab with rebar projecting to connect to the adjacent slab. At the core, you'd probably have that top slab finished, but throughout the rest of the building, you might use a slab with exposed rebar and do the final pour in the field, so you're reducing the weight for transportation. Above that, you can see the walls around the shafts. These are rated firewalls, and so they have to be concrete and they have to stand up to about 3 hours of fire. This is a twin wall system in which the 2 external faces are produced in the factory, and then the sandwich in between is poured in the field. These are put in place and held up temporarily with props, and then the pour is made. And finally, on the right, you see the stairs as they're dropped in. Now, these stairs could contain the rails and guards areas, but they might be just stairs by themselves. The reason you want to try to put these in as quickly as possible is this is a convenient way for workers to take their tools and get access to the floors where they're working without having to use man lifts or other things on the side of the building like scaffolding. Reducing man lifts, reducing scaffolding, and reducing formwork is part of the way that we make these products operate more efficiently. Okay, the last example I'm going to go to is about some of the MEP systems and what we call vertical circulation, stairs and elevators. There are systems called jump lifts that will let you use a mobile machine room, and so every 3 floors you're able to place a temporary moving machine room so that workers can now take heavier tools and equipment up in a temporary elevator And at the end of the project, that becomes the permanent elevator for the building. We won't focus on that today in process, but we will show a little bit about MEP, stairs, and twin walls. The second example in this slide is showing horizontal MEP units, first placed on the ground and then lifted in place and attached to the ceiling in the building. And then the final system is a vertical MEP module or a riser. So let's switch now from these products that I've talked about to the processes by which these products are delivered.
Perfect. Thank you for that, Patrick. So this is on screen at the minute. A very common scenario which I've seen throughout the industry and not just in the construction sector, you'll be pleased to hear. So it's essentially a team will win a large project with some sort of data and specifications behind it. And then this information then needs to go out to several other teams and stakeholders who are actually going to complete the work. Those teams you'll generally find will have multiple sub-teams within them. And maybe even sub-teams within those again, and they're all likely going to be using a different software or a different version of the same software. They might have different formats. Often they might be using different versions of files, and for them integrating their work is going to create great difficulty and be really time consuming. So of course what we're going to talk to you about today is there is a better way we could do this. So this is where we think 3D Experience comes in. So before I talk to you about the nitty-gritty of Delmia and the benefits behind that, just to give you a brief overview of 3D Experience. So some of the key things you need to understand for this is we're talking about using one source of data. That is a big driver for this, where the latest data is available throughout the business at all times, and there is a data history there if you need it too as well. So essentially what we're going to do as a process for the site is we're going to bring in the construction site data, whether that's from Revit or SolidWorks or any other software. We bring that into the platform and connect it, so that's updating constantly and it's always available for whoever needs it. From that we're going to essentially do our process plan and do our 4D build-up. From the 4D build-up, this is where we're going to start to allocate equipment, so things like cranes and pump trucks and things like that. And then at this point, we can start to do the real special stuff within 3D Experience Delmia. I've started to do some of the great simulations, which we're going to show you a little bit later in this presentation. So what does that mean for that image you saw before? So we've gone from a fairly messy system, I think, to a much more cleaner solution here, where we have 3D Experience in the middle, and what we have there is we can pull in data from loads of different sources if we need. So if people are working in Revit or things like that, we can connect that into one platform which always has the data there for anyone to use and if they need it. So you can have your structural team, your MEP team, your architectural team all working, maybe they're working separately on their 4D plans or their data, but as the structure is updated, that's instantly available for the architectural team and MEP team to see those updates. There's no import and export there. And then it's not just 3D as well, we're talking 4D too. And that's where we start to get to really interesting stuff, where you can very easily actually synchronize your plans between structural, MEP, architectural, and create what we're kind of coining this on-site digital twin, where you get a true digital version of how this thing should be built. And from that, hopefully start to see these new opportunities for further enhancement and optimization. So just to show you, to start off, I think it'll be great to show you this video, which is a industry example. So exactly like we said before, the first thing you'll see in this is we've brought in the construction data. So here we have a simplified model for NDA reasons, but so you have your model from, if that's from Revit or anything else, and from that the Revit model might have been structured by the architects in a very specific way, which makes sense to them, but doesn't really make sense to me as a planner, because actually I want to do this floor by floor, which isn't how they've structured their data. So here you can see I'm very visually just taking the CAD and just creating this process where I'm splitting it out however I need it, to make a little bit easier for me as a planner. without affecting the architecture structure. And then from that, I'm then creating a process plan where I'm actually going to define what floor comes when. So if I'm going to build the first 3 floors and then I'm going to kick off my MEP teams, or maybe it's down to the specifics of I'm going to do this wall, then this wall, then this wall. So that sort of level. I would always say here you want to go start as high level as possible and then really focus that in later. So you don't want to instantly start thinking I'm going to simulate every single bit of bolt and nut and false work for the site. Always start as big picture as possible because it will become obvious the key areas that you need to build the processes for as you build this system. And then from that, we can obviously do some more clever things like create Gantt charts and look at the process and analyze it a bit more detailed as well. And the idea here again is the process can be very visual, created in a visual way. But if you prefer working through spreadsheets, that does exist as well, where you can build that that way too. The idea being there's multiple ways to do essentially the same thing. So you as an engineer can work how fits you best essentially and be most efficient. And then from that we get some of these great 4D build-ups, which hopefully you guys have seen something similar before, but I think Delmia does do it in a special way. So it automatically generates your Gantt charts, as we said. And yeah, so from that, just before I show you the good stuff, linking back to Patrick's section before of modular processes and products, from that 4D, you now have a 4D build-up of hopefully not just your structure, but your architectural elements and your MEP and any other elements for the site as well. And you've linked your resources to that as well, so you can see the cranes and things like that moving around. So hopefully it should be really clear at this point to be able to identify repeat products and processes for the site. So in this example we showed you on screen before, we took the core structures and said, hang on, there's 6 core structures that are all identical here. So if we optimize one of those core structures, in theory we've optimized all of those core structures. And then going deeper into that, the core structures are all built exactly the same way. So the precast elements within them, we could optimize all of those installations, and then we're actually optimizing potentially hundreds, if not thousands of pieces of equipment. And then as well, there was things like stairs and MEP risers and bathroom pods, kitchen pods. Could be loads of different elements which you can see are repeat products or repeat processes throughout the site. So at this point, you've identified loads of these key products and processes. You have all your 3D CAD for the site, hopefully, or it's in some sort of stage, maybe not a finished stage, but that's okay too. You can start in a concept stage. You have your process plans, so you've put some effort into how this is going to be built, and hopefully you have your resources defined as well. So you've done a hell of a lot of work. You've done the bulk of the work at this point. So this is where Delmia, for me, becomes something really special, because you've defined all those things. So why leave it there? Why not use all of that digital information to really optimize your site and understand it further? So this is where we come into our advanced studies of simulation work. The simulations essentially. So using all of that information already set up, we can go beyond that 4D plan using off-the-shelf Delmia applications such as equipment simulation, ergonomics, assembly evaluation to try and study and optimize these repeat products and processes. So just as an example of what I mean by a scenario here for simulation, if you were looking at filling a precast structure in a specific location, there might be 3 different ways to do that. So it might be, the first way is pouring from the skip on the using a crane to fill those precast walls on any part of the building. The second might be for the lower floors of the building, you could actually use a mobile pump truck next to the concrete truck. The third might be maybe you're going to use a portable concrete mixer which is dropped onto the floor which is needed, and the concrete is going to be pumped up to that portable mixer. Of course, there could be loads of different options throughout the site as well, which I won't mention here. But essentially, how do you know which one of those is right for a site? So you might just have someone who is an absolute expert and they know this is the best way to do it. But using Delmia, we can actually digitally test all of those scenarios and put real data against those methods. So you can now know that option 1 these are the pros and cons, and it fits this type of site really well. Or option 3, whilst it doesn't work for that sort of site, it works really well for this other sort of site, which is slightly smaller, which is fantastic. So it's more data-driven decisions for scenarios, essentially. And then from that as well, going back to single source of truth for these advanced studies, the Revit files, Tekla files, SolidWorks files are now all connected, so updates to those stream automatically into these optimization studies too. So if you have an update for the site, you can really quickly see how that's going to affect these simulations, which is fantastic. And some of you are probably sitting back and thinking, that's a lot of simulation work, which if I'm going to simulate every single wall being installed and every single slab and every single column, you're going to increase my workload by quite a lot. And I would agree. So that's why it's really important to not get carried away with simulations in this sense. And what you're trying to do is find the bottlenecks. So you should be able to identify the bottlenecks through these, through your 4D plan and through these repeat processes. And what you're trying to do is find the areas that are maybe 20% of the build, but they hold 80% of all of your bottlenecks. So if you can optimize those and really improve them, it's really going to affect the improvements of how quick this thing is built or how efficiently it's built and things like that. So just on that note, so as an example, it could be that you're looking at things which are happening maybe hundreds or thousands of times on site. Such as pouring a concrete column. To do that, you need to place the rebar, set the formwork, pour the concrete, vibrate the concrete, let the concrete cure, strip the formwork, and that needs to be done for every single column on the project. So those are the kind of highly repetitive activities which you may want to optimize on the site. So to show you some of these simulations, we're going to start off with a crane simulation, which is the video on the top right, which I'll play now. So what you're seeing here is a crane which has been fully defined in the software. So we've set that up exactly how we would set up a robot from a manufacturing facility. And so it has the real height, the real boom length, the real attributes, all the real limits to it. So as I move that hook, it's moving the crane with it as well. And for me to just check the position of that goods in location, you can see I can see all the joint limits on the crane and see that that's well within the limits, which is great. And then if I want to as well, I can grab that virtually and move it and do the installation, which is fantastic. But here, the really interesting thing, which is why I'm showing you this, is hopefully there's some of you in the audience who are drivers. And with looking at that parking of that truck, I'm thinking they have done an awful job of parking. They are across the curb, they're blocking the pavement, and just to the right of it, you probably can't tell this, there's actually another goods in location not too far from that. So potentially it could be blocking that too. So if you're proud of your work, you're probably going to park parallel, right, to the curb. You're going to do a good job and park well. So moving the truck as we did just there, you can see straight away that's flagged that this is actually out of the crane limits. And zooming out, I can actually see that the boom is right at the end of the limits, which tells me that's a problem. So we actually phoned up the team on site and said, hey, look, we've simulated this. It took us like 20 minutes. Did you know? Is this right? Have you had this problem on site? And they only found out a couple of days before we did this piece of concept work for them that problem was actually on site, which caused them a big headache of how to solve that. So if you'd have looked at that early on in the project, you could have either just moved the crane, extended the boom length, or maybe even looked for an alternative goods in location for all of that area. So, and very quickly and easily solved that issue. So just to give you a bit of variety as well, so on the bottom video here, I'm just press play on that. So we also have a example of assembly evaluation. So here we just took one of the props and we're looking at how that's going to be installed. So we went for a prop in a very tight location through this wall and installed in a bit of a tricky area. And again, it's as simple as you just click and drag it and you move it and you press play and you check it for collisions and see what's going to happen there and see if it can be reached. So a really nice quick way of validating something that's difficult. And here we're showing a prop, but that could be an installation process for a tricky wall. It could be for the MEP risers, which are going to be really tight. Could be for some specialist equipment on site. Could be for the stairwells. Could be for anything. So it's a really powerful tool for de-risking and optimizing processes. So third and final. So I'm going to show you a ergonomic simulation now as well. So first thing we have here is, again, so we've defined all the 4D build-up, we've defined all the 4D plan. So for me to do this, all I need to do is go into that process as an ergonomics at work specialist and press the step in the process, and it will automatically jump to where that 4D plan is at that step in the plan. So at this specific step, this wall has just been installed. So as an ergonomist, I've been told to check this as they think it's a risk area. So you can see I'm very quickly manipulating a digital crew member or operator and just checking how they're going to balance, if they can actually reach that prop to install it. And this is going to be a really tricky prop here to install. And you can obviously see there's a big drop there into the core, which tells me straight away there's a risk of them falling or having just no access essentially to install this bit of the wall. So there's a second one here as well, which I'll skip a little bit ahead of in the video, where we're going to walk around to the opposite side of the same prop installation. And here we have a different scenario where it's maybe not a case of they're going to fall in the pit unless they roll over into the core. It's more of actually an access problem. So just pressing on the prop, you can see they can quickly grab it and check the access, and it's really tight. But if I pause it here, you can see it's actually the pink and the green prop are causing some problems there, and that's more of an access issue. So as the ergonomist, I can not only go to my team and recommend some improvements for safety. So we need to put some sort of cap to make sure they're not going to fall and really hurt themselves installing these props, but also, is there actually a planning improvement that could be made here? Could the walls which are being propped by the pink and the green be installed after the grey prop, which we're trying to grab here, which straight away would give better access ergonomically and improve the process for that operator? So that's real data driving those optimization decisions even before it's on site, which is great. So the next thing is, you've done all of this work. How do you actually capture that data though? You don't want to be doing, as we said before, like hundreds and thousands of ergonomic simulations or thousands of single walls being installed. That's going to take you all day, all year. So what we can do is just catalog our findings. So if it's resources like cranes or trucks or equipment, we find that once, we set it up once, we put it in a catalog so we can use that on the next project or reuse it in the future. It's no longer this great resource which we know that one person in the company has, but we can't quite remember their name, and it's in a USB stick and in their top drawer. It's just in the business now, which is fantastic. And the same goes for processes as well. So when we talk about these repeated products and processes, it could be something like a bathroom pod or a precast wall or precast structure offsite. But again, it might be actually something where it's a standard process, but maybe the 3D isn't the same. But we know the process is always going to be the same for installing that column, but it's going to be a different X, Y, and Z. So we can store that process and reuse it on the next project if it's been optimized and things like that. And the big thing to note on here is we're essentially trying to take knowledge out of the head of expert individuals who potentially could leave the business or retire or God knows what else, and we're trying to bring that knowledge into the business rather than just in their heads. So if they leave, it doesn't matter. That process is there for whoever the next person is to find it quickly and access it. So then lastly, to kind of summarize, I put down a couple of trends, construction sector trends, which I think are really key here for Delmia. So the first one is being able to unlock big models is really what's kicking us off in Delmia, and we're seeing all of these new simulation possibilities and 4D planning opportunities. And this has really come from, if you think back 10 years ago, it was really commonplace to see a single robotic cell being simulated, which was really fantastic at the time. But now it's much more common that you would see an entire assembly line being simulated in robotics, or an entire production line in a factory. And then that's leading us to now starting to do entire buildings. So we're on that much bigger scale than we used to be, and where data is now just way lighter, software is way more powerful, laptops are way better, and we can just cope with bigger data and bigger models such as construction sites. And then again, as me and Patrick have already discussed, modular design is a real driver, which is fantastic because that's leading us to modular processes, which make a big difference for the site. And then with those modular processes, we can go to a much finer granularity with Delmia. So if you see a bottleneck, you don't need to go to the site and do loads of testing to optimize it. You can do that digitally before it even hits the site, to a level which could not be done as quickly or as efficiently before. And then something we've not really touched on in this session is with modular processes and modular design, you can start to probably find some products which could be moved off-site to a factory to be optimized even further, so it just arrives on site and there's minimal installation to do there. And obviously a factory brings all the benefits of that come with it, which is great. And then lastly is that connected supply chain. So maybe where we have these offsite factories, we have multiple suppliers who are much more regular because it's a factory-based environment. We have our on-site teams, our architects, our partners. We can start to build that connected supply chain as an industry to really drive the construction sector forward, which I think we're going to start to see in the next few years. So unfortunately, whilst I could very easily, and I'm sure some of you know, talk about Delmia digitalization pretty much all day or even all week, that does wrap up my time slot for this session. So one area I wasn't able to go into detail but has vast benefits and applications within construction is offsite factories. But as a teaser of how Delmia can really tackle this factory environment, I'll leave on screen 2 videos playing whilst Patrick and I will do our best to answer any questions you hopefully have. And yeah, from me, thank you for listening, and I'll pass back over to Patrick.
I hope you've been able to join us live for our session today so you can ask questions, and we'll be glad to answer those. If not, let me summarize what we've covered. We think it's important that companies begin to capture knowledge about their best practices, both in how the products are made, in a configured order as opposed to a bespoke design system, and they also capture knowledge in process. So the 7 systems we talked about is what's the best way to install stairs and the right sequence and the right level of product. Should the stair contain rails or not? Should the stairs be put 1 floor ahead of where the workers are or kept in sync with the workers? Each of these practices of what you build and how you build it needs to be captured, and with each project you capture more knowledge about improving the systems as you go forward. In addition to stairs, today we talked about different types of slabs, finished slabs that you can walk on immediately, or slabs with exposed rebar that are a lighter weight product. We talked about twin walls, walls that are fire separating key areas of the building, partially made in the factory, partially poured in the field. We talked about different types of support systems, columns with shear caps or columns that use beams. We also talked about certain types of mobile machine rooms that allow a portion of the elevator to be used during construction, and it's extended as it goes. We talked about horizontal and vertical MEP distribution systems. While these are just 7 systems around the core, there's dozens of different products that need to be thought through from both the point of view of how to manufacture, how to assemble in the field, and the logistics to connect those things. How do they fit on a truck? How are they loaded onto the truck? how are they lifted off the truck. I hope these 7 systems are enough to give you an idea about a different approach to designing and planning process for construction. Thanks for your attention today, and thanks for joining.